Hello everyone. Today in this video, let's check out some of the physical properties of alkenes. Now, alkenes they resemble the alkanes in most of their physical properties, except in isomerization and difference in the polar nature. Now, the first three alkene studies are ethene, propene, and butene. They are gases, and the next 14 elements are liquids, and then the higher alkenes are solids. Now, ethene is a colorless gas with a faint sweet smell, and all other alkenes are colorless and they are odorless. They are generally insoluble in water, and they are fairly soluble in non-polar solvents like benzene, petroleum ether, CCl4, etc. Now, it is known that the alkenes have higher boiling points than that of alkanes. Why? Alkenes have higher melting points than alkenes. The alkenes have higher melting points than alkenes. Now, why? Now, if we check out in alkenes, the single bonded carbon, the carbon atom is sp3 hybridized. Therefore, the S character is 25%. Now, however, if we check out in alkenes, that is the double bonded hydrocarbons, unsaturated hydrocarbons, the S character is nearly 33.33%. Therefore, since in alkenes the S character is high, is in the case of alkenes, the electronegativity of the carbon atom is also very high. Therefore, since the S character is high, electronegativity is also high. Therefore, it results that in alkenes the force of attraction is also very high, and therefore, since electronegativity is high, it ultimately shows that the force of attraction would be high, and therefore the melting point is high. And also, it can be known that the pi electrons are more polarizable than the sigma electrons. Therefore, it can be shown that the force of attraction in alkenes is stronger than alkanes, which makes the alkenes, the double bonded hydrocarbons, have higher melting points than the single bonded carbon atoms. Now, if we check the boiling point is a tendency where it increases with the increase in the number of carbon atoms. The boiling point increases with increase in the number of carbon atoms. It is well known to us. Now, if we consider the geometrical isomeric alkenes, cis alkenes, they have higher boiling points. The cis alkenes these are cis, and then this is our cis, and then trans. Since cis alkenes have higher boiling points than that of trans alkenes, because here in cis alkenes the vectors are in the same direction, and then the polarity adds on. Therefore, the addition of vectors and this dipole additive. Now, however, in the case of trans isomer, the dipole here, it cancels out each other. Therefore, since isomer will have stronger double interaction, since it is in the same direction, they will have a stronger double interaction, and therefore the cis isomer will have higher boiling points than the trans isomer. Now, if we check for the solubility, as I have said, the alkenes, they are insoluble in water. However, they are readily soluble in organic solvents. There are salts such as benzene, CCl4, ether, etc. Therefore, these are some of the physical properties of alkenes.